Welcome to AP Pre-Calculus 1.12, working on transformations. We actually broke this up into two parts because it is pretty loaded. So what's really important to know is our vocabulary in AP Pre-Calculus is very specific, so we do need to know our vocabulary. We'll be going over that, and let's just get rocking and rolling. Additive transformations is the first thing here on the left side. So let's talk about that. So we call these additive transformations, we call them vertical translations and horizontal translations. So what's important to know is that we have input transformations, output transformations. Okay. Anything that's outside the function is output. Anything inside the function is input. So please do take note of that. So outside. Hello. I can't write on this thing. Let's try that again. So outside is output. By the way, affects the y's, affects the range. Inside, I don't even know what that was. Inside, input. Okay, so if we're adding a k value on the outside, we're just vertical translation. It could be up or down. If it's negative, it's down. It's positive, it's up. No big deal. All inputs, transformations, are always the opposite of what you think. So if we have a f of x plus h, we're actually translating it by a negative value. So just be aware of that. The inputs are always going to be the opposite signs. All right. So let's go ahead and describe this transformation right here of f of x for the first one. So this is going to be we have to state it as a vertical translation. I can't even spell. Of 7. Okay. Vertical translation of 7. Oh, yeah, I lied. I'm just looking up there. Of f by 7 units. I'll be consistent with what the notes say up here. Of f. Oh, no, we don't even have f. Wow, 2 mistakes in a row. Probably should restart this video. Oh, my garage. By 7 units. Okay, that's how you see it written if it's multiple choice. For 2 there, this is going to be since it's on the inside, say input, this is going to be a horizontal translation. Of g of x by negative 7 units. Okay. Let's just pop right up here for a multiplicative now. So if it's, again, on the outside, it's going to be vertical because it's going to be output. It's going to be a vertical dilation. We call it vertical dilation of f by a factor of the absolute value, whatever that is. The reason it's absolute value is because that's how much we are really stretching it. So you can think of it that way, a vertical dilation by how much we stretch it by. If it's on the inside for input, it's going to be opposite of what you think. So instead of multiplying by b, it's going to be dividing by b. So it's going to go by a factor of 1 over b. Quick little note here. If a is negative, this is for the vertical dilation. If a is negative, this is a reflection over the x-axis. Okay, we don't deal with negatives for the horizontal dilation, so I'm not worried about that. Okay, so describe the transformation of f. Okay. I just noticed another mistake. This shouldn't say of g of x. This should say of f, because g of x is our function, and we're just trying to move it. Really should restart this video. Nah. Let's be authentic here. Okay. So this one's going to be we're just going to copy it down. This is a vertical dilation. Of f by a factor of positive 4. So I'll just write 4. Okay. And then for 2, it's on the inside input. It's a horizontal dilation. Dilation. Oh boy. My handwriting's not really good in this video either. Of f by a factor of, now it's 1 over b. It's 1 over 1/4, which is equal to 4. Okay, so just flip it. All right, let's do better. Okay. Given the function of f here, here's f, sketch g. So all we're going to do here is we're going to, you can think of it this way. We're just going to go down to, it's a vertical translation of -2. We're just going down to. Think of it that way. That's not how we would write it out, but we can think of it that way. So take all these points. Since it's already in blue, I'll do this in red. So take all these points, go down to. Okay, so it looks like we kind of sort of got a parabola here. Parabola and then linear. Okay, super simple. Let's do this now with the stretch. Okay, so, or as vertical translation. So we're going to take all of our y values and we're going to double them. Okay, so if I'm looking at this far left point, I'm going to multiply that by 2. Next point, multiply that by 2. Next one, multiply that one by 2. This one is down here at -3. Multiply that by 2. I'm down here at -6. So it looks like this. So vertical translation looks like a stretch. I'm sure that's how you learned it in Algebra 2. So there you go. That's what a vertical translation looks like. Let's do the same thing here on the next page. But now we're going to be affecting the inputs here. So you can think of it this way, is that we are going opposite, right? You would think that we're going left to opposite. We're going right to, because it's inputs opposite. So take all these points and go right to. This one right here. This one we're going to compress. Okay, you can think of it compression, because it's going to be this is going to be dilation of a factor of 1/2. So take all of our x values and multiply them by 1/2. So since this x value on the far left is a -2, it becomes a -1. This one becomes a 1/2, and this one, which is out here, 1, 2, 3, 4, 5, is going to be 2.5. Okay. If you notice, the one that's on 0, nothing happened to it. I think that change there was the input. So we just really got tighter towards the y-axis. Okay. I'm just making sure I don't have any more errors. Just doing this mentally in my head. We're fine. Okay. So let's go ahead and combine some of these transformations. We're going to describe these transformations in the correct order. Order does matter. We go in PEMDAS order. PEMDAS order, for our purposes here, is we care about the multiplying, dividing parts within F, and then we do the adding, subtracting. Okay. But furthermore, the parentheses is what comes first. So we really do the inputs, everything on the inside first, and then we do the outputs later. Okay. So for this one right here, here's our order. Our order, if I'm just picking out the numbers, parentheses first, inside is going to be the 1/3 comes first. We'll worry about that in a second. then the multiply, which is the 2. And then last but not least, we'll do the 4. Okay, so what's the 1/3 doing? Okay, this is a horizontal dilation by a factor of its input opposite. Instead of at 1/3, we flip it 3. Then for the 2, we have a vertical dilation by a factor of 2. And then the 4 is going to be a vertical translation of, I'll put a positive 4 right there. Okay, so that's us naming everything in that order right there. Okay, so that's me describing my transformations. All right, so the graph of f, this one's a tricky one a little bit. I feel like this is going to be a pretty commonly asked question on an AP exam. The graph of f is shown to the right. We know what g is. I want to find the domain of both f and g. F is the easy one because we have it. So f domain is going to be from, which is x is from -2 to 5. Okay. The range of f is going to be from low to high, from -1 to 2. Okay. I just use interval notation because I think it's a little bit easier to do. For g, it's important to know what's going on for g here. This is going to be domain only for the inputs because everything on the outside is output, which is range. So what's going on for the domain? I'm shifting everything really to the right 1. So we're going to add 1 to my domain. Okay, so the domain for g, we're just going to add 1. So we're going to get -1 and 6. For the range, might need to show a little more work for this one. The range right here, I'll do that in blue. So range, I'll do that one in blue. I'm going to make sure this is in the right order, multiply by -2, which means that I'm reflecting it over the x-axis. I'm going to multiply by -2, then add 3. So I'm going to do -1 times -2, and then add 3. So -1 times -2 is 2, plus 3 is 5. I'm not going to write it down yet because I want to do this in the correct order. Okay, so this is going to be 5. And then for the 2, multiply the 2 by a -2, and then add 3. That's just going to give me a, maybe if I was good at math, I would know this, -1. Okay, so 2 times -2 is -4, plus 3 is -1. So now make sure you put this in the right order. It's not 5, -1. It should be -1, 5. Okay. Moving on down. Select the values of the function are shown in the table above. We have g, which is just giving us just the generic transformations here. So we have a, which is a vertical translation. We have h, which is a horizontal translation. And then we have k, which is a vertical translation. Sorry, a was a vertical dilation. Okay, this is in the xy plane. We have trillion transformations in order. So we have a horizontal translation by 1 unit. We have a vertical dilation by a factor of 4 and a vertical translation by 5, down 5 units. What's the value of g of 2? Okay, so really, if I'm looking at this, I need to find what a is, what h is, and what k is by reading this, all vocab. So just by reading this, look at a. Which one of these statements represents a? And I mentioned it was going to be a dilation. So this is going to represent a. So a is equal to 4. H is going to be our horizontal translation. So horizontal is right there. So it's going to be my H. It says right 1. Input opposite. So this is going to be -1. And then let's go ahead and look at the last one, which is k, which is a vertical translation down by 5. So k is -5. If I put this together, my g of x is now going to be 4 times f of x minus 1 minus 5. So I'm going to plug in a 2 now to find g of 2. So 4 times f of 2 minus 1, which is 1, minus 5. What is f of 1 according to this right here? F of 1 is 5. So this is equal to 4 times 5 minus 5, which is 15. All right, and that is going to wrap up our video here. If you notice, we have a whole other day of transformations coming up, so do not forget to like and subscribe.